So, if you're anything like us, you've probably felt that dizzying late year rush of major tech announcements.
Oh, yeah.
We call it the AI sprint.
Yeah.
It's that period where every lab, from the open source challengers to the biggest walled gardens, they just drop their best experimental gear right before the
They
holiday.
really do. And the pace is just, it feels like it's accelerating even as the year winds down.
It's a massive wealth of new tools and ideas,
Hmm.
but it's also, I mean, it's a massive wave of noise.
It is. And we have to be careful not to mistake movement for progress. The market is absolutely maturing. And the days when simply making a model, slightly bigger, brought massive immediate gains,
Mm,
those are ending.
right.
The focus is shifting, and it's shifting dramatically from just raw size to differentiation and actual application.
Exactly. We're in such an interesting moment. In just the last few weeks, we've seen three major, really anticipated model launches. Mistral 3, DeepSeek V 3.2, and of course, Anthropic's Claude Opus 4.5.
But that's not all.
Not even close. On top of that, you have renewed debates about the core principles of AI progress, like are the scaling laws dead or just incredibly expensive? And maybe most importantly for your digital life, a huge business clash.
The Amazon story.
Amazon just locked one of the most useful AI agents, ChatGPT's shopping tool, right out of their ecosystem.
So our mission today is to dive deep into this flurry of activity. We're going to try and unpack all this information to identify the defining trends that actually matter to you.
Yeah, we're asking not just what these models can do, but really, how is the competitive landscape evolving?
We'll structure this dive by looking at model specialization first, why labs are choosing very specific niches. Then we'll tackle that computational cost of progress and ask who can still afford to innovate at the cutting edge.
And finally, we'll hit those business incentives, the turf wars trying to put, literal walls around the open internet and what that means for the dream of a general purpose agent.
Yay!
Okay, let's jump straight into the model blitz. The central paradox we're dealing with now is that there are just so many good models.
So,
So many.
it's getting genuinely difficult to distinguish the newest best thing from the newest second best thing. You have these three new heavy hitters. You've got Gemini, you've got all the ones we already use.
That difficulty, though, I think that proves the market has matured. It reminds me of that famous memo that leaked out of Google way back,
Yeah.
suggesting there is no moat because the foundational tech, it'll eventually just be great and commodified.
We're here.
That moment is here.
So, if the technology is becoming commodified, how are these labs? I mean, you've got the open source projects like Mistral and DeepSeek, and then the heavily funded closed labs like Anthropic. How are they managing to carve out specialties? How do you stand out when everyone is good?
It's all about strategic differentiation. It's about choosing your specialty.
Okay.
So take DeepSeek 3.2.
Okay.
Their differentiation is rooted in efficiency and high-level reasoning.
Right.
And what's really fascinating here is their focus on yet another novel attention mechanism.
Yeah.
Specifically, sparse attention. Hold on, let's unpack that for a second. Sparse attention. What is that, and why is that their chosen path for efficiency?
Well, think of it this way. In a standard transformer, the model has to look at every single word in the prompt and every word it's already generated to figure out what to say next. It's a lot of work.
Super inefficient.
Sparse attention is a really fancy architectural trick where the model learns to ignore the unnecessary junk and only pays attention to the most important, relevant tokens.
It's like speed reading for an AI.
Precisely. It's a perfect analogy. It lets them run these giant models much more efficiently, which means they can afford to prioritize complex reasoning first. They are clearly optimizing for deep analytical tasks.
So things like agentic workflows and tool calling.
Exactly. They see advanced reasoning, not pure scale, as the next big frontier.
So DeepSeek is aiming to be like the sharpest mathematical and logical tool in the shed.
That's the goal.
How does Mistral 3 compare? Because they usually play in that open source space where cost is a huge, huge factor.
Yeah, Mistral 3 takes a fundamentally different path. They're focusing on utility and accessibility. And surprisingly, their architecture is described as being a relatively plain vanilla transformer. They've deliberately avoided a lot of the really complicated attention scaling that DeepSeek just embraced.
That sounds like a trade-off, though. If they're sticking to a vanilla architecture, are they less efficient?
Well, they're betting on simplicity, on reliability, and on utility for the enterprise user. Their major innovation is making multimodality so, built-in vision standard across their entire model family.
Even the small ones.
Even the tiny ones, like the 3B parameter version, for them, vision isn't an add-on feature. It's baked in as, bread and butter.
That makes them instantly useful in so many business cases.
Yeah.
You can feed it a financial chart or a diagram, and it just works.
Exact.
This must make them incredibly strong for enterprise RD systems.
Absolutely. And ORGI, for anyone less familiar, is retrieval augmented generation. It's how companies let an AI search their giant internal library of documents.
Right. Their policy manuals, emails, their entire code base.
Before answering your question, Mistral's combined simplicity and vision capabilities make them a fantastic backbone for businesses building those internal knowledge bases.
Okay, finally, let's look at the proprietary powerhouse. Claude Opus 4.5 from Anthropic. Where are they choosing to specialize?
Anthropic is doubling down hard on software engineering.
Right.
They are aiming to be the best developer model shop on the planet. They're explicitly targeting the idea of a digital worker.
What does that mean, a digital worker?
Think of a virtual engineer that isn't just good at writing a single function, but can read and interpret an entire 200-page software specification document. Something a human developer rarely has the time or, frankly, the mental capacity to do.
I saw one report that mentioned a surprising detail about Opus 4.5's conversational ability, the so-called vibe check.
Yes.
It apparently showed real long-term memory, making a callback many turns later to something you thought it had forgotten.
Yeah.
Is that focus on a human-like voice, a real differentiator, or is it just clever marketing?
That's a fascinating point, and it really highlights the divide in use cases. For the general consumer, someone who wants a relationship with their AI, that human-like memory is paramount. It feels more capable.
Or reliable.
But if I'm a developer using the model purely for, say, technical code checking, I'm just looking for a functional sounding board. I want the most accurate, quick output possible.
I want the facts, nothing else. Thank you, wipe the memory, goodbye.
Exactly. The sophistication of Opus 4.5 shows they can nail both, but their core strategy is about choosing these high-value domains, the reasoning lab, the developer shop, rather than just trying to be the best at everything.
Which brings us to the conclusion that we're probably moving toward a world of hybrid architectures.
I think we have to be, where systems use a kind of router to ensemble these specialized models.
So you send the task to the right specialist,
Mhm.
DeepSeek for the complex math, Mistral for the vision and documents, and Claude to review the code.
That ensemble approach just makes sense, especially if the cost of building one single master model is just becoming astronomical.
Speaking of cost, that whole idea that bigger is not always better transitions perfectly into this renewed debate on scaling laws.
Yeah.
We just saw a really compelling argument from the VC Thomas Tongas, suggesting that Google's recent advances with Gemini 3 actually prove the scaling laws are still pretty good
A very big
if you have truly unparalleled access to compute.
The central question here really is whether that linear progression of scaling laws, where performance improves reliably as you add compute, is still relevant for everyone, or just for the elite few operating at Google scale.
So if the scaling laws still apply generally, why are these other world-class labs like Anthropic and DeepSeek prioritizing efficiency and specialization instead of just doubling the parameter counts on their new models?
It comes down to vertical integration. If scaling laws still apply at the cutting edge, they absolutely rely on that unparalleled access to compute. And Google is unique. They've vertically integrated the entire stack. They design their own hardware, the TPUs, and they build the software to run on it. No one else has that kind of dedicated, controlled supply chain.
So for, 99.9% of the labs out there, the old scaling law is essentially irrelevant because they can't afford the infrastructure?
Progress is still happening, but it's not widely distributed in that same way. And we also have to look at what Google is actually optimizing for.
Okay.
What's fascinating here is that the improvements aren't just about adding more parameters. If you look at Gemini 3, the model kept roughly the same size as Gemini 1.5.
Oh, about 1 trillion parameters?
Right. The breakthroughs are algorithmic, which implies they're focusing on something like context engineering, where the model is simply better at grabbing large, relevant context before it generates a result.
So they're not just making the brain bigger, they're making the process of accessing external knowledge far more efficient.
Yes. It's like our own biological scaling. Our brains haven't changed much in thousands of years, but the tools and data we can access have just exploded.
It's a great analogy.
So you have to frame the scaling curve not as this, smooth, straight line.
Right, not this predictable slope,
Exactly. But as a stepwise function.
like climbing stairs.
Yes. Progress happens in these massive jumps caused by breakthroughs in new algorithms or new tech. We've sort of found an equilibrium on raw size, and now we're building better tools and methods around that size.
This sounds like we need to redefine the core concept we're even using.
We do. The traditional scaling law, which always related to increasing floating point operations, is a bit of a misnomer in modern AI. I think the true competitive breakthrough we're seeing is defined by an experimentation law.
An experimentation law. What do you mean by that? This is where it gets really interesting.
Model training is just staggeringly expensive. We're talking tens or hundreds of millions of dollars and months of time.
Right.
When hardware gets faster and better, it doesn't just allow for bigger models. It accelerates the ability to experiment with the vast, unexplored hyperparameter space of training.
So you mean the literally millions of dials and knobs, the learning rates, the batch sizes, all the layer configurations that dictate how a model actually learns.
Yes. We have only explored a tiny fraction of the possible ways to tweak and tune that training process. If Google's TPUs let them iterate through those combinations 5 times faster than a competitor on standard GPUs, they discover those quality improvements, the algorithmic leaps, 5 times faster.
So the speed of iteration is the real scaling factor now.
It is, and that is a direct function of who owns the infrastructure.
That speed of iteration leads directly into market access, into competition. The ultimate goal of all these models is to interact with the world, but that world is suddenly building walls. We have to talk about the walled garden created by Amazon. The big story here is Amazon blocking ChatGPT's new shopping research agent from accessing product data, deals, and reviews.
And this is so much more than just some minor spat.
Oh, absolutely.
It's a foundational challenge to the whole agent paradigm. It immediately makes a product like the shopping agent less effective. Imagine you used it a few weeks ago.
Yeah.
It could instantly compare Amazon deals, read dozens of reviews, and spit out a summary. Now, it's neutered.
Because Amazon is just a key pillar of online infrastructure. If the agent can't access that data, it has to search 5 smaller retailers and then ask you to go check Amazon separately.
Which destroys the user experience.
Completely. So what were the core motives? Why did Amazon lock the door so decisively?
Well, they have 3 really powerful reasons. First is just ecosystem protection. They want to protect their e-commerce data from being scraped and ingested by third-party AI tools.
Standard defensive play. Makes sense.
Second, business model protection. They need to maintain absolute control of the shopping funnel.
Of course.
If ChatGPT facilitates a sale and directs the user to the final product page, Amazon loses control of that transaction's revenue stream, the ads, the commissions, the traffic metrics.
They want you to start and end your journey on Amazon, not with a third-party intermediary. And the third motive?
Self-competition. Amazon is pouring massive resources into its own AI-driven shopping services.
Right, like Alexa Plus and Rufus.
Exactly. They cannot, in good conscience, let a competitor train on their data or funnel customers away from their own proprietary future AI systems. It's a classic move to eliminate competition before they even get started.
This explicitly marks the beginning of the turf wars. It's open, general-purpose shopping AI versus these closed retail empires.
I wonder if this pressure will eventually lead to smaller retailers banding together, maybe creating a collective open agent layer to compete against the big elephant.
That might be the long-term hope, but the immediate consequence is just the stifling of the core value proposition of agents.
The dream was a single general-purpose agent to handle everything on the internet for you.
Right.
To reduce complexity.
Right, one agent to rule them all. But this move by Amazon, and you couple it with similar moves by companies like Cloudflare, which is now blocking agents by default, it strongly suggests that business incentives are actively destroying that unified dream.
The fear is that we're just returning to the dreaded app world.
Ugh.
But instead of different apps, you'll need a specialized Amazon agent for Amazon, a specialized agent for Google Search, and a different one for everything else. You lose that seamless, user-friendly flow.
What's fascinating here are the legal and market implications. I mean, agents may become the new browser.
It feels like that.
We've seen this script play out before. Historically, when these tight, vertically integrated ecosystems preclude competitors, I mean, think about the early browser wars when Netscape was choked out. Those monopolistic tendencies are eventually challenged.
And it's hard to imagine the internet remaining functional if every single major platform builds a wall around its data and forces you to use their specific AI. The fundamental tension is just so clear. The value of these new models and agents relies on them being able to search and synthesize the global data structure. But the business incentives of the companies who own that data demand they protect their moat and monetize access themselves. That conflict is only going to escalate.
So if we step back from this frantic late-year sprint, two major defining takeaways really stand out for you, the listener. First, AI progress is no longer defined just by size.
Not at all.
It's now defined by specialization, choosing a specific domain, and by ensembling the best model for the task.
And the second takeaway is just as critical. The ability to execute on the grandest scales, whether that's through proving the scaling laws or through controlling data access, is increasingly defined by who owns the infrastructure.
That infrastructure dependency is the key tension driving the future.
Yeah.
We're seeing this parallel trend where both model scaling and agent functionality are becoming wholly dependent on who owns the biggest systems.
Which leaves us with the big provocative thought for the week.
Does this mean the future of AI innovation is defined less by algorithmic brilliance, less by the open source scientist who writes great code, and more by who owns the infrastructure and the data pipes? More by corporate business models.
And if that's true, what does that mean for competition? And what does it mean for the everyday consumer who just wants the best tool that can search everything?
Something to mull over as you explore these new specialized models.
Thank you for joining us for this deep dive.
We'll see you next week.